Okay. So this is a shorter module, but this is what our materials folks do, especially at the plant, the not the material handlers, but the planners, the plant planners. These guys are always chasing parts. And they're usually cussing out the CM for putting this crappy supplier in place just because they're cheap. It's the way it goes, man. All right, so develop and or execute plans and metrics to reduce risks of shortages. So monitor and control the three main costs of inventory. So ordering costs, what does it cost to create a PO, receive the PO, pay the supplier? Inventory holding costs, we've discussed before. This is when you're sitting on material. You've got finance costs, ownership costs, risk costs, overhead costs. And it generally runs anywhere from a third to 3/4 of the cost of the part for a year. Here's another look at the same thing. It just breaks them out in a little bit different groupings. This is how ISM breaks them out. Inventory shortage costs, the costs associated with schedule changes and missed orders because the necessary parts weren't available. You'll see this often. We try to put some contract language in there that says, if you miss trucks, we can charge you. Most suppliers won't go for it, but we try. Holding too much inventory to avoid shortages costs more in interest payments on working capital. So again, the working capital is the need that comes from you buying the parts and then you getting money from your customer. So, when you buy the parts, you usually have around 30 days to pay the supplier, but you're not usually going to receive payment from your customers for at least 60 days because you got to build the thing, you got to sell it, and the customer's got to pay you. So the more inventory you hold, the more working capital you're going to need to bridge this time between the time you have to pay the supplier and the time you get paid. And then if interest rates are rising, it's going to cost you even more because what you're going to do is go to the bank and get a loan. So cost ties to shortages, lost production downtime. We see this a lot. We could be producing 80 trucks a day, but we're only able to produce 65 because we just can't get enough parts. Idle workers, I don't know if they really have this issue at the plants. They could. Lost sales due to empty shelves. Well, we get lost sales because we're booked up, but then we can't meet all our commitments. Emergency shipments, expedited shipments. Yeah, we see that stuff all the time. And dissatisfied customers. Hopefully we don't see too much of that. Measurable cost of inventory, item costs plus holding costs, inventory holding costs, order costs, and shortage costs. That's another way of looking at it. Inventory levels should be reviewed periodically to balance demand with desired service levels. Service level is desired availability of inventory to meet demand as a percentage. So if you want to have 95% service level, that means 95% of the time the part will be in stock. To calculate a service level, you need to find the Z-score, and if you've had statistics at all, you'll remember how to do this. But, here's some common Z-scores. 90 is 1.28, 95, 1.64, 98, 2.05. And then there's a formula you can use. And this guy will go through it ad nauseum if you really want to figure out how to do that safety stock level. But the problem is that when you go, well, we want 95% available. I mean, that's a big number of parts you're sitting on your shelf, and you're going to have to eat all that working capital cost. So, this is good in theory, but most companies aren't going to stock that kind of safety stock. Here's the formula, the Z-score. times the standard deviation of the lead time. This kind of walks you through how to do it. I don't think you'll have to calculate this for the test. Given the variance, this is, you want a 95% available, and the 90% available is the 1.28, and then it tells you how many stock keeping units. So 1,500, it's like, wow, that's a bunch. And that what this is taken into account is the variability of your demand. Conduct an ABC analysis on the parts you sell, have higher service levels for the A parts. So A parts, again, are the 20% of the parts that cost, or the 20% of the spend that has 80% of the parts. Or 20% of the parts that has 80% of the spend, sorry. Early warning processes used to identify risk of part shortages. So you got manual systems, like Kanbans, things like that. So when your Kanban has 10 left, or min-max system has 10 left, you order 100 pieces based on your lead time. Usually you use this kind of min-max Kanban system for low-level C items. And then there's automated systems in MRP. You just tell them you want a 95% service level, and they'll do all the math from this previous page here. But again, you get to looking at how much inventory that is, and people start freaking out. So market intelligence, gathering and analyzing information about commerce in a specific commodity. What's the market trend, up or down? It's the buyer's market, seller's market, etc. I don't know why that's in there, but it is. Replenishment strategies. There's two general strategies. There's the fixed order quantity, which means the size of the order remains fixed, and while the time interval between orders will vary. So you're always going to order 500 pieces, but you may order it in 1 week, may order it in 2 weeks, etc. And variations of the fixed order quantity, such as the economic order quantity, or EOQ, or min-max systems, determine the size of the fixed order type system. So usually used for independent demand, which is not the part on the BOM, it's the top level of the BOM in an order point system. So Kanban, min-max, EOQ systems, these are all fixed order quantity systems. And then you've got a fixed order period system, which is a set time frame is established to review the demand data and establish an order based on demand. The quantity will vary, the review time frame will not. So this is your MRP system, and you're reviewing the orders every 24 hours because the system batches or renets every 24 hours. This is a periodic MRP system, and you go and look at your orders again. Most people don't use a perpetual system, which would immediately update because they're just too nervous and they give you conflicting signals all day long. Inventory policies for optimization. Goal of all inventory policies is to minimize inventory levels while meeting the customer requirements. And why do we want to minimize inventory? Because of working capital, it costs money. Min-max replenishment. Decide the minimum amount, the stock that will trigger a new replenishment order. Works great for the C-type items, usually based on average daily demand rate and number of days. Max refers to the maximum amount that will be ordered at one time. So if the minimum is triggered at 10, an order for 100 pieces will be placed, for example. The order size is based on the average daily demand and the supplier lead time. So here's how you'll see questions on this. This ISM likes this way of figuring out safety stock. And here is another ISM article. I think this is another one of these monthly metric things. Yeah, monthly metric on safety stock. It'll kind of walk you through how they like to do safety stock, and it's this formula here. So maximum daily usage, how many pieces do you use a day, times maximum lead time. So lead time can vary between 3 and 5 days. You'd use 5 there. minus the average daily usage. So if this is maximum daily usage is 500, the average may be 400 times the average lead time, which may be 3.5 days. So if we got maximum lead time 7, an average lead time of 3, and a maximum daily usage of 1,000 and an average of 500, we're going to do the maximum side first, which is 1,000 times 7, max lead time times max usage, and then do the other side next, which is the average daily usage times average lead time. And you subtract one from the other, and you get 5,500 in safety stock. Still a bunch of safety stock. What we'll try to do at PACCAR is we don't want to pay for this. What we try to do is push it on down the supply chain to tier 2 or tier 3. But understand, if you're requiring the supplier to hold safety stock, it's going to cost money, and they're going to want to be compensated. And if they don't get compensated, they might go out of business because they go broke. All right. Joanne Reed is the materials manager for Acme Inc. She has a part out on the factory floor, which is a bug screen for the trucks that Acme makes. The personnel on the factory floor are very inattentive to the bill of materials and simply put a bug screen on every truck that comes down the line, even if the BOM does not call for it. It's just easier. The factory personnel feel bug screens are cheap, so buy more. But it's on an MRP system, and Acme is constantly running out of bug screens. So what should Joanne do? Basically, her inventory is always wrong. What do you
I'd
guys
go with
like here?
A.
Yeah, it should want, but obviously they're not enforcing it. So this is actually something that used to happen in Renton that I was involved with. And they're just
D.
going to, yeah, it's probably going to be D, because A is what should happen, but they're probably just going to ignore you out on the factory floor. Let's see. Yeah, D. If they're not reading the bombs, the computer generated fixed order system will not work. But then like about A. It's likely to backfire. The production personnel already feel that the bug screens are cheap and should go on every truck instead of wasting time reading a bomb. So yeah, you might not win that battle. All right. What are the 3 main types of costs for inventory? So which one doesn't belong with the others? Or no, which one is the 3? So you kind of compare them all together and see how they're different.
I would lean towards B, ordering cost, holding cost, and shortage cost.
Yeah, because these two are pretty close. It's just the difference in risk costs. I would go with B too. I think it comes from this question, this chart back here. Holding costs, item costs, order costs, and shortage costs. But let's see what we got here. Oops. Yeah, B. Okay. So there's 6 questions out there. You guys go get on them and raise your hand when you get done, or otherwise we'll go over to like 351. Okay. Let's go over some answers here. There's a lot of math on these questions. All right. Option 1 is option C, and it's the max usage times max lead time minus average daily usage times average lead time. I think this is the one that has the red herring in it. Yeah, so all this stuff about defective parts, it's not applicable to the question they're asking. They just throw that kind of stuff in there to get you thinking, what am I missing? 2 is delta. If chart turns slower, there's a bigger gap between when you have to pay, so you need more working capital. 3 is Charlie, and I didn't even get all the way through this one. This one's pretty complicated, and I doubt you'll have to do this in a test, but you can read the answer and walk yourself through it if you're interested at a later date. 4 is alpha. Again, this is the same ISM formula, max daily usage times max lead time minus average daily usage times average lead time. And 5 is Bravo. Because you can do 95% service level for C stock, that's just cheap, but you can't do it for your A and B stock. And then 6 is Delta. All MRP software are either perpetual or periodic, with most being periodic. Systems will generate orders on a daily or weekly basis, depending on the system. So the time is fixed, but the quantities vary. Any questions? All right. If not, we'll talk to you guys tomorrow.
Yep, talk to you then. Thanks,
All right.
Rick.
Yeah.
Thanks, Rick.